Let's now keep talking about Meterpreter detection, but this time I'm gonna use some forensic tools. Especially I'm gonna use OS forensics in combination with volatility to analyze a memory dump that I'm gonna create just now by using OS forensics. Okay, I chose the location where to save the memory dump and I started doing this. And it's gonna take a while. Now that we have the memory dump, we can analyze that with volatility to see what kind of processes were running on this Windows 7 system. And if we have a look at the results, I don't see anything relevant to Meterpreter here. There doesn't seem to be anything important. Same stuff if we try to find malware in our memory dump, nothing suspicious pops up. Let's now move to a different tool that I downloaded from GitHub, promising to detect a Meterpreter payload in memory. It's an application written in C Sharp, for I can understand, to run this. Let's now run this tool from command line. What it does is it analyzes all the running processes for anything malicious, especially Meterpreter payloads. And so far, nothing malicious seems to pop up. I'm not 100% positive though my previous Meterpreter payload was still in memory. So I'm going to exploit the machine once again. And now I'm back in. And let's now see what this tool does if it detects anything. I'm gonna restart the scan here. And you'll notice something popped up. It was highlighted in red. And it was essentially the Meterpreter payload running in memory that we just created. I redirected the output to file, so you'll notice the Meterpreter payload in these lines here. Let's now have a look at the system with an online antivirus scanner because Microsoft Security Essentials didn't signal anything suspicious. So, though we know there was malware, and in fact, there are a bunch of infected files here. I'm now using Veil to obfuscate my payload, and I'm gonna check it again to see what happens, if it gets detected or not. I'm gonna use the shellcode base64 encoded payload. Hoping the encoding will be sufficient to obfuscate its signatures. Now I had to enter the IP address of the listening host and the port. I'm gonna use a dynamic port. Okay, we generated our payload and now we move it to the Apache directory. Let's also start Apache service so we can access the payload from the other end. We generated the payload successfully, and it's an executable. Now can go to the other end, and you'll notice all the malicious files that were detected. Let's now run the tool again, and let's see if something changed when we used obfuscation. Let's see if it made any difference or not. I might probably have to rerun the payload, but you'll notice that it was detected in the end. Even without having to materially exploit the system from Kali, simply running the payload was enough for it to be detected. You'll notice that I tried to exploit the system to open another session, but all my efforts are frustrated, and every time I try to pop up a shell, the tool blocks my Meterpreter payload. You see that I'm trying to open a session, and every time that happens, I don't get a session. The command prompt hangs. In fact, on the other end, you see the Meterpreter payload is detected, so I can't get to get a shell. Alright, so I hope you enjoyed this video. There's more stuff around about Meterpreter detection, way more advanced, and you can have a look at Black Kill's webinars if you want to see something really awesome. Anyway, I hope you enjoyed the video. Bye bye.